Here we look at the last material from Chapter 7. We figure out what to do with all these rational expressions and equations we've been working on. And the two main topics are proportions and variations. And then by the time we get done with this, we'll be ready to review for the next test. So proportion we've already seen. They're a statement that two ratios are equal. So for example, we can write a proportion like this. 1/2 and 5/10 are equal to each other. So a proportion simply says that two ratios are equal, or two fractions are equal. And so when we cross-multiplied before, we were using this property that says that if these two things are equal to each other, then the two outsides, which are the A and the D, the two insides, which are the B and the C, if you multiply them, they're equal to each other. Look at my little example in red up at the top. 1 times 10 is equal to 2 times 5. That assumes that the two denominators are not 0, and so you can use these to solve for missing pieces. You can use these to find out if the statement is true, right? If I gave you 1/2 equals 5/9, then that's not a proportion, right? 1/2 and 5/9, multiply 2 times 5, you get 10. 1 times 9, you get 9. Those are not equal to each other. So if they're not equal to each other, then it's not a proportion. So here's an example. On an elliptical machine, Chris can burn 370 calories in 25 minutes. If he increases his work time to 30 minutes, how many calories will he burn? Assuming that, the ratio stays the same as he increases his number of minutes. So let's try to keep our units consistent. So if I have calories and I have minutes, let's set up my proportion so that the units are the same in both fractions. So he can burn 370 calories in 25 minutes. If he increases his work time to 30 minutes, now minutes go on the bottom, so they have to go on the bottom over here also. How many calories will he burn? So I'll let X be my number of calories. All right, cross multiply. 25 times X equals 30 times 370. I'm going to grab a calculator for that one. 30 times 370 is 11100. So 25x equals 11,100. Divide both sides by 25. And that gives me 444. And then I just check to see if my answer makes sense, right? If you can burn 370 in 25 minutes, then increasing the number of minutes by a little bit should increase the number of calories by a little bit. If you get an answer like 7,000, that's probably wishful thinking, but not realistic. Go back and check your work. If your number of calories went down, then I got bad news for Chris that the more he works out, the fewer calories he burns. That doesn't make sense either. So you may not know exactly like what if you got 443 instead. How would you know that's wrong? You wouldn't, but at least you can check and see if your answer is reasonable. If he increases his workout time a little bit, he should expect to increase the number of calories that he burned a little bit. All right, these are the old-fashioned shadow problems. 6-foot tall person casts a shadow that's 8 feet long. If a tree casts a 32-foot long shadow, estimate the height of the tree. So we're estimating the height of the tree. We're not sitting there with a tape measure trying to measure how tall the tree is. That would be really tough, especially if it's an enormous tree. But we can certainly measure people's shadows. We can measure people's heights, and people know how tall they are. So from here, let's try to solve that. So this is a tremendous problem. I've got a person and I've got a tree. So here's my tree. Trees are green, so we'll make our tree. There's our tree. Tree casts a 32-foot long shadow. The idea is that these things are all similar triangles. That's the height of the tree, and I don't know what the tree is. The 6-foot tall person casts an 8-foot long shadow. So right away, I know that the tree is going to be shorter than 32 feet. Because look, the person casts a shadow that's longer than they are. So because you're standing at the same spot under the sun, the tree is going to cast a longer shadow than its height as well. Okay, so when I get my answer, that'll be one thing that'll let me know whether or not my answer is reasonable. This guy's happy sitting in the sun, so we'll give him a smiley face. How does my proportion work? You can set this up really in 4 different ways. Just be consistent. So if you want to do the height of the tree over the shadow of the tree, then you have to do the height of the person over the shadow of the person. Oh, but what if you wanted to do the height of the tree over the height of the person equals the shadow of the tree over the shadow of the person. So you got the height of the tree over, oops, sorry, I gave my guy a couple extra feet there. Height of the tree over height of the person equals shadow of the tree over shadow of the person. Try cross multiplying these. Notice you're going to get the same thing, right? In both cases, you'll get 8 times h equals 32 times 6. In the one underneath, you'll get the same thing. H times 8 equals 32 times 6. Even if you flip both fractions over, even if you do shadow of the tree over height of the tree equals shadow of the person over height of the person, or the other way around for the other one, you'll still get the same thing. So it's possible to set these up in more than one way as long as you're consistent, because when we get to the end, we're all going to come up with the same equation. Right? We'll all come up with 8 times h equals whatever 32 times 6 is. 192. Okay, divide that by 8, and I get 24. So the height of the tree is 24 feet. And again, a lot easier than climbing the tree with a tape measure to try to figure out how tall it is. All right, from there we can move on to variation. So you can have two types of variation. You can have directly proportional and you can have inversely proportional. For directly proportional, what that means is as one goes up, the other goes up, and they go up as a line. Right? So as the number of hours you study for a test increases, then your grade on the test increases. As the number of hours that you lie on the beach in the sunshine increases, the amount of your suntan or sunburn, depending which way, increases as well. So as one goes up, the other goes up. The more miles you drive, the more gasoline you use, or the more electricity you need to charge your car, depending what you drive. So look at the way this is worded. Y is directly proportional to x, or y varies directly as x, if y equals k times x. We have a name for k. We call it the constant of proportionality. In reality, it's the slope of the line. When you set these up, look to see how the question is phrased. So this one says x is directly proportional to y. So this is not y equals kx. This is x equals k times y. Right? So if x is directly proportional to y, x is 2 when y is 5. Find x when y is 10. Right? So x is 2 when y is 5. That means I can solve for k. I can solve for that constant of proportionality. K is 2/5. Right? So x is equal to 2/5 times y. It says find x when y is 10. Right? Notice that 10 divided by 5 is 2, times 2 is 4. So as the x's go up, the y's go up. X is 2 when y is 5. Find x when y is 10. All right, the same thing can be done with the other one. It says c varies directly as d. C is 27 when d is 33. Find c when d is 11. So c equals some constant times d. Let's throw in some numbers. C is 27 when d is 33. If I divide both sides by 33, 27 over 33 can be simplified. 27 divided by 3 is 9. 33 divided by 3 is 11. All right. Look how nicely this is set up, though. Find c when d is 11, so we go back to our original equation. We want to find c. We know that k is 9 over 11. We know that d is 11. The 11s cancel top and bottom, and we get c is 9. Right, what if this problem was given to us in table and graphical form? So the table lists the amount of pay for various hours worked. 6 hours pays $138 and so forth. You can read down the table. We're assuming that this person makes the same rate, that they don't get more for, like, let's say they work more than 20 hours in a week, then maybe they get a little bit extra. No, this person's making straight time all the way through. So find the constant of proportionality. If I tell you that they're making the same pay all the way through, then all I really need to do is set up one simple little equation and divide. All right, so if 6 hours at certain amount of pay gives me $138, all I need to do is divide both sides by 6. All right, so take 138 and divide it by 6, and I get 23. So this person's making $23 an hour. Try it for 11. see if I'm right. Do 11 times 23, and you'll get 253. So again, assuming this person makes the same pay, they're making 23 bucks an hour. I can write this equation as their pay is equal to 23 times the number of hours they worked. So now the question says predict the pay for 19 hours of work. Well, I don't have to predict it. I can tell you what it is. If he works 19 hours, it's going to be 23 times 19. Of course, we're talking before taxes and all that. But 23 times 19 is 437. And again, it should make sense. It's more money than working for 15 hours, but less than working 23 hours. All right, the other type of variation is what we call inverse variation. So we say y is inversely proportional to x, or it varies inversely. So as the x's increase, the y's decrease. So the more number of hours you spend at the beach, the lower your math test grade goes, or something like that. Right? So as one increases, the other decreases. The more hours a week you work, the less number of hours you have for leisure time. There's another example. As the x's increase, the y's decrease. So it says let y be inversely proportional to x. Y equals k over x is the formula for this. Suppose y is 6 when x is 4. Find y when x is 8. So the formula is y equals k over x. It says suppose y is 6 when x is 4. So y is 6 when x is 4. We want to get rid of the 4 from both sides, so multiply both sides by 4. K is 24. So now y equals 24 over x. It says find y when x is 8. So 24 divided by 8 is 3. All right, so y is 6 when x is 4. Y is 3 when x is 8. So as the x's increase, the y's decrease. Right? So first I find my k value, then I substitute it back in with the other piece of information to solve for the missing variable. All right, one more. G varies inversely as h. So G equals k over h. As the h's increase, the g's decrease. G is 3. H is 48. So I multiply both sides by 48. 48 times 3. On this side, that goes away. 3 times 8 is 24. Carry the 2. I got 144 for my k. Right, set up the same equation again, except this time we're going to replace that k with 144. It says find g when h is 2. So 144 divided by 2 gives me 72. Let's make sure that answer makes sense. G is 3 when h is 48. G is 72 when h is 2. So yeah, the h values went way down, the g values went way up. Okay, so that's inverse variation. And that's it. That's the end of Chapter 7. The next set of tasks to do after this video is done being watched is to start the review for test number 2.